Hello, welcome back to my tech farm. I'm Igor, and in this video I would like to introduce you Ender-5 S1 3D printer, and this box is sent to me by the Creality 3D official in exchange for a review. This is cubic firm cartasian, and actually this is my favorite structure of the printer. Over the bed slingers, it has the advantage that it has a smaller footprint, more stable printing, especially with bigger objects because it doesn't move. And even the ABS, if we don't have the enclosure, it's easier for printing because we don't have that moving air around the object during the bed slinging. Over the Creality printers, the advantage is that it is simpler, easier for maintenance, shorter timing belts, easier to place attention on them. Let's see some specifications. First of all, I noticed that they claim on the website that it can print on 250 millimeters per second speed.
I'm not sure is it really the printing or just a traveling speed. The acceleration is 2000 mm per square seconds.
The print volume is 220 and 220 in X and Y direction, same like Ender-3, and 280 mm in Z. It has 4.3 inch touchscreen. The printing temperatures, it has all metal Hotend, so it is able to print on 300 degrees Celsius, and the bed it can be heated up to 110 degrees Celsius. It has direct drive dual gear extruder, which is also a big improvement compared to the regular Ender-5, which means that we can even print some flexible TPU filaments. It has auto bed leveling sensor, that's CR touch, which will touch the top of the surface. And it has flexible print sheet. With this we can remove the object much easier with starting to flex it, and we don't have to fight against the whole surface like with the glass. I noticed that on the website we can buy the enclosure too, but only the side panels, but even this can significantly improve our printing, let's say ABS filaments, because don't forget, the bed will be heated up to 100 degrees Celsius approximately with ABS, and the heat goes up. And if it prevents the side air moving, like with this paper now, in that case we have a bigger chance to print even taller ABS objects. Of course, perfect would be if we can some kind of tent or something like that on the top, and in that case the complete temperature inside would go up to maybe 50 degrees Celsius, but even with those side panels I'm sure that we can have a lot of success printing ABS parts. But let's see what's in the box.
And as usual, everything is nicely packed and protected inside this black foam. And we have at least 3 or 4 layers of the parts and the tools for this 3D printer.
This is content of the box, user manual. This is assembled Z-axis, stiffening brackets, sample PLA on the small spool, and this is the top frame. It is quite pre-assembled already, the extruder and the motor, everything is on it. These are the vertical alloy extrusion, and they are 40 by 20 millimeters. And this is the bed, and you can see it has a nice thermal insulation from the bottom. This is the base, spool holder, power cable, scraper, tools and bolts for assembling. And the pliers, and one thing I'm missing here between tools, and there's the metallic tweezers instead of this scraper maybe.
First step of the assembling is mounting these vertical alloy extrusions to the base of the printer with 2 bolts from the bottom. And they are labeled with these stickers, so it is very easy to follow which goes where. Next is mounting the top frame, which is also pre-assembled, and here again we have to use 2 bolts from the top.
3.3 installing the Z-axis kit, bed to the Z-axis.
Next is mounting the Z-axis, which is quite pre-assembled. We can use this black foam as a support for the bed until we prepare it, connected with the 4 bolts, and then turn it upside down. And after this I can mount these supports from the bottom. Actually, these supports are one of the first upgrades which we usually do on Ender-5 Pro, the older version. And then installing it to the main frame from the inside. Fixing with 4 bolts, and the Z-axis is prepared. Then we have 2 pieces of the stiffening brackets from the plastic.
The position of the spool holder is here, but this is not really the natural path of the filament when we are using the direct extruder. I'm not sure that this will be my final solution in the future. Connecting the cables is easy because the cables are labeled, only we have to know which is the X and Y axis. This is Y axis. X-axis and the direct drive extruder cable. D is filament detector. Z-axis. Hotbed cable, the notch goes to the right side. It is important to check the voltage, is it set correctly for your country. In my case it's correct to 30 volts. In US, for example, it should be 115 volts. And it is important to check the tension on the V-slot wheels. As you can see, this rotates too easily. And I will use the open-end wrench on the eccentric nut. And it's okay now. The tension is set correctly now, but as you can see it wobbles a little bit, so I'm not too happy about this solution. Maybe they could use 20x40 alloy extrusion here if they don't want to use the linear rods or linear rails. Next step would be check the tension on the timing belts, but they are all set correctly, and that's good because it is not so simple to set the tension. Usually we have some kind of tensioner here. There is a space, but probably they don't want to extend from this alloy extrusion.
This is more compact solution. Installing this Bowden tube, which is actually just a guide between the filament holder and the direct drive extruder. It's a good idea to chamfer the edge a little bit from the side which goes to the filament sensor. It will be easier to insert the filament. Doing some cable management according to the instructions. In my curiosity, I want to see what is inside.
Approximately I was familiar what I will see. So this is the power supply unit. The output is 24 volts, 14.6 amperes. And this is the screen. This is the slot for the SD card if you want to update the firmware of the screen.
This is that annoying buzzer, so you can put something inside this hole and some stick tape to make it quieter a little bit. If you have some other solution, then write me suggestions in the comment section.
This is the main board, and we have 4 stepper motor drivers, and these are high current wires. I hope it can be seen on the screen. They have ferrules on them. And this is the slot for the full-size SD card.
Okay, let's press back this cover and let's discuss a little bit more about the printer.
Quick overlook. So this is the base with the mainboard power supply unit and the screen inside. This is connector for the power cable, but don't forget to check the switch behind to is it set correctly with the voltage for your country. It is very nice that we have now more rigid frame structure, because these are 20x40 alloy extrusions, and we have these stiffening brackets on both sides. Now this is a little bit confusing to me that we have a Z limit switch on the bottom, but this also have the sear touch auto leveling sensor. So currently I'm not sure how it works. This only have one lead screw and 2 linear rods, so it is supported this bed on the one side only. And one of the most popular upgrades on Ender-5 Pro was basically this support, and it is good to see that here they provide us these supports, and with this the bed is more rigid, its position.
For the feeling, this bed is very similar to the soft magnetic from the Ender-5 Pro. I think it could be more rigid.
Because if you print ABS on this surface, and let's say we have great adhesion, the ABS, if it starts warping, it may lift these corners. Good to see that finally they place here a notch, so the positioning of the build plate is much easier.
If you want to use the build plate from other printers, let's say Ender-3 because it has the same size, we can simply remove the 2 bolts, and in that case it can be used.
Here we can see 2 improvements actually. One is this thermal insulation from the bottom of the heated bed, and the second are these silicone mounts instead of those springs. Not my favorite position for the spool holder, because this is direct drive extruder, so more netter filament pad would be from the top. Yes, we can print some kind of filament holder here, but we have to find a solution to move this filament sensor too, and also the wiring must be extended. This is direct drive extruder, and the part cooling is from 2 sides, but only from the one fan. So we will see how it performs the cooling, because theoretically this is able to print on 250 mm per second speed. But I think this kind of part cooling is not enough for PLA, but for ABS or anything else, yes, because ABS doesn't require any part cooling, or very minimally. It's time to turn it on and prepare it for the leveling. First let's try moving of the axis. Let's see in X and Y direction. First it will do the homing. Y and Z. First it will do the homing of the Z, but Y at the bottom? Okay, there is the limit switch. Axes are moving correctly, only I'm a little bit confused with this Z limit switch. So I'm not sure why they didn't use the sear touch for the homing of the Z, because now with every homing the bed has to go down to press that limit switch, and this is the reference. Much more logical would be if the reference point is here using this sear touch. So this is much slower process of the Z homing, and also the question is the accuracy, because the reference is now from the bottom.
And the third is that we have to change the Z offset with every bed type change. Sear touch would touch the top of the surface, but in this case that's not the case. Different thickness, different Z offset.
This is the home of this screen. From this we can start the printing, but currently I have no SD card inside. And here we can move the axis, insert the filament, or set the temperatures on the nozzle or on the heat bed. Additional settings, leveling, here I will start the leveling, and here you can set the language, 9 languages. Firmware 1.05.
Let's start with the leveling process, and first it will start with the homing. And with silicone columns we cannot compensate too big differences. First important step is to set the Z offset with some paper sheet in the center. And then we can start the manual bed leveling. With this we can make the bed parallel with the moving path of the nozzle.
Well, in my case I have the same friction in all 5 points, so in my case the leveling, automatic leveling, doesn't have to compensate anything at all, but that will be my next step.
The auto leveling also starts with homing of the Z, and after this the sear touch will touch several points on the bed, and any inaccuracy will be compensated during the printing.
Leveling is finished, so first I set the Z offset, then I do the manual leveling, and after this I do the automatic leveling. This means it will create some kind of offset mesh, and if there is any inaccuracy in this surface, it will be compensated during the printing. Of course, that's why it is important that manual bed leveling, the best is if it doesn't have to compensate anything at all. And now it's time to preheat the nozzle and do some test prints, which is on the SD card.
Well, the inserting of the filament will be much more comfortable if the spool holder would be above the extruder.
Preheating PLA.
It's good that the Teflon tube is removable from the extruder, and with this inserting of the filament is much easier.
So it was tested with some black PLA.
And let's print something from the SD card, which is prepared by the manufacturer. And every print will start with this homing process. This means the bed will go completely down, pressing the Z limit switch, and then goes up.
Printing started correctly. I was prepared to lower the Z offset if necessary, because I used double sheet for leveling the bed. But let's see what kind of settings we can do during the printing. This is the screen we can see, and if I tap here, then we can set the nozzle temperature, the heat bed temperature, we can set the fan speed, and here we can set the Z offset if it would be too high or too low. Heat bed temperature, runout sensor, it's on now. This is the print speed in percentage, probably this is on 100 now. And the power outage, it is on, the power loss with some function. This is maybe useful if we do some printing in spiral or raise mode, then we can turn off this function, but we will test this later.
And with this printer I can create much nicer time lapses.
Printing is finished, let's check the bed adhesion.
It was printed in 24 minutes. The bed is still hot a little bit.
The adhesion is quite good, maybe even too good, but it is good that it is flexible, so I can easily remove even bigger objects.
No stringing between ears, and a nice overhang on the bottom of the face.
2 files, let's see the second one, maybe it's the Benchy.
Yes, it was the Benchy, and this is the time lapse of approximately 1 hour.
Printed in 1 hour and 5 minutes.
This overhang surface looks great. This means the part cooling is okay with this printer, even with the PLA. And this Benchy looks great, and I couldn't even find the seam line, so somehow they hide it in this G-code. It's time to prepare my own G-code, and I can do it using the Creality slicer, which is just a rebrand of the older Cura, but at least we can add this printer very easily because the profiles are prepared for it. Or I can use the Ultimaker Cura, but currently the Ender-5 S1 is not supported in this list of the printers. This means I will add just a little bit different printer, and I will change just volume. And I will copy the start and end G-code from the Creality slicer. And important to mention that I removed the G29 from it because I don't want that auto leveling before every print. I prepared the calibration cube in both slicers, theoretically setting the same speeds, and here you can see the time lapses side by side, and the one prepared in the Creality slicer was printed much faster. It was printed in 14 minutes and using the Ultimaker Cura 22 minutes. This is big difference, and the printing was started after the preheating the bed and the nozzle. Faster, but we can see the difference in quality, so significantly more ghosting along the y-axis, but also along the x-axis too. The Z is very similar, and also the first layer too. I believe that this printing along the y-axis would be much nicer if we would have more rigidity in this alloy extrusion, let's say using 20 by 40 alloy extrusion, not 20 by 20, or linear rails. Next test object is just a cylinder printed in spiral or vase mode printing.
The printing is smooth without any breakings in the movement. I know earlier this was the problem, but it looks like the problem is solved because sometimes this some power loss function interrupt this smooth motion of the spiral path. But maybe it's better to check if this is enabled at all. In the menu I can see it is enabled, but let's check if it works. It's preheating and it should continue with printing. Oh, it's homing the Z. And now X and Y homing. And it works. It is good to see that the problem is solved, but if you still have the problem, in that case you can here disable this power loss resum function, or you can disable it in the G-code too by adding this line at the beginning. Printing was finished without any problems and the surface is smooth, only here we have some extra material from the oozing of the nozzle.
And except on that one point where the nozzle stopped during the power loss, this cylinder looks great, outside surface and from the inside. And whenever I see the printer I'm measuring the noise, so another printing is in progress, all fans are working now, and I will measure the noise from exactly half meters distance from the closest point of the Hotend. And this data I will add to my summary table on mytechfun.com website, link in the description.
Direct drive extruders always like to test with TPU filaments too, and this is the softest I have at home. On Shore scale the hardness is 85 and it is like a rubber.
This is a time lapse of 2.5 minutes and it was really hard to insert this filament, pushing it into above the tube. Everything started correctly until it didn't start with retraction, because I'm printing 9 pieces at once. And this direct drive extruder can pull the filament without problems, but with retraction it has to push it back into tube, and that's really challenging. And I know this from feeding the flexible filament into this Teflon tube.
And I think it's printing in the air, so it has a problem with this too soft filament. Looks like this filament is too soft for this direct drive extruder. I could play a little bit with the tension, but let's switch to TPU 90. The adhesion is good, so I'm sure that this is not the problem. This is TPU 90, the Polymaker's softest filament, so let's try with this one.
The feeding was easier with this filament, but I still needed 2 minutes for this. Well, it struggled with this retraction, but the printing was finished without stringing, so this means the retraction worked.
And this time the printing was finished correctly, and these are legs for this rolling dice. And my last printing for this video will be on higher temperatures. This is filament ASA, and I will print a cap for this M5 board, and I will print it on 270 degrees Celsius.
It started correctly, and I didn't use the brim, but it will stick too good, you will see. So a good advice is to check the Z offset with the preheated bed too.
Printing is finished without brim, and quick bed adhesion check. Oh, great. I have to wait until the bed cools down, of course. Ooh. This was hard to remove. Probably I have to set the Z offset with the 100 degrees Celsius bed. The skirt is coming down easily, only the object was stick too good. The conclusions, and I will split them what I like and what I didn't like with this printer, and I will start with what I like, and here you can see the full list, just in case if I forget to mention something. I really like this type of the printer, the cubic frame cartasian. Great rigid structure, very nice direct extruder which is able to print on 300 degrees Celsius. And the nozzle is also bigger, so it can really print on those higher speeds. It can have a bigger flow rate, which is required for printing on higher speeds. The bed is insulated from the bottom, and it can be heated up to 110 degrees Celsius. And great that it didn't use the springs but the silicone mounts. With this we don't have to do that manual leveling so often. It is fast printer. Compared to the bed slingers, approximately 2 times bigger speed, or let's say half printing time we can get with this, but we have to sacrifice a little bit with the quality. Also, I really like that they use the full-size SD card and not that small TF card. And now what I didn't like with this printer. Let's start with the firmware. Okay, so during the printing, the current Z coordinate should always be visible. Whenever I am waiting some color change or some critical bridging, but the current Z coordinate should always be visible on the screen during the printing. I hate that beep sound on the screen when I touch it, so next time I will upgrade the firmware on the screen. When I open it, I put some stick tape to make it quieter. And I mentioned several times, I hate this limit switch on the bottom. I asked in the Facebook group what is the reason for this, and I have the feeling that everybody works for Creality there, but I'm sure that this is not a good solution, because every time I do the homing, I just want to change the Z coordinate, just move a little bit lower because I cannot see the nozzle whenever. It always starts with the homing and takes time. The second is the accuracy is a little bit questionable because the reference point is now on the bottom. And the third point, if it will use the sear touch as the reference, it always touches the top of the surface. But with this switch, if I replace this bed, and I do that very often because I have several from Ender-5 S1 Pro or similar, every time I have to set the Z offset, or otherwise if I use the thicker bed, it will hit the nozzle. So this is very important, and that's why, even from the safety reason, the sear touch would be much better solution for the Z homing. And now about that flexible filament printing. Well, this is direct extruder, but it struggles a little bit with the printing with these TPU, softer TPU filaments. And a reason for this, well, even feeding of the filament was quite hard into this Bowden tube. Even it is reverse, so this means the extruder pulls the filament, but during the retraction it pushes it back, and in that case this Bowden tube works against this extruder, and probably because of this the retraction is very hard, so very minimal retraction we have to set, but in that case we will have more stringing with printing those softer TPU filaments. Definitely a very smart upgrade would be if the spool holder would be somewhere here on the top, but we have to find a solution how to move this filament sensor below that spool holder, and in that case we don't need this Bowden tube. Overall it is great printer, huge improvement compared to the Ender-5 Pro, for example. And well, these kind of things which I mentioned here would really make this printer perfect, but the problem is that Creality don't really listen to me. Okay, if I would give these suggestions to the Sovol, Iligu, 2-3s, whatever, basically they integrated into their new products. Sometimes they even contacted me without video to give some suggestions about the new products. If you have some other experience with the Ender-5 S1, write me a few lines in the comment section. Thank you for watching and happy printing!